demonstrated leadership in cloud migration, DevOps, and IoT solutions that drive digital transformation and business growth. Our lecturer competency, including cloud architecture, data center migration, cloud security, DevOps and automation, disaster recovery, infrastructure as code, AWS control tower, AGS, HC2 and PPC, cost optimization strategy, agile cross-functional team leadership, voice integration, IoT system integration, and many more. Also, our distinguished speaker have many certification from AWS, including Certified Solution Architect Professional, Certified Solution Architect, Certified SysOps Administration, Certified Security Specialty, Certified Machine Learning Specialty, Certified Advanced Networking, and also many more. With more than 16 years of experience, of course, we will get many knowledge from our distinguished speaker in today's general lecture. To Mr. Siladitya Sharma, please present your presentation. The time is yours, sir.
Yeah, sure. Thank you. Thank you for the nice introduction. Um, Let me share you my screen. Oh, I need to open the system settings. Just a second.
Ibu Nelly sudah di-co-hostkan untuk diizinkan share screen?
Sudah, Pak, sudah.
Oke.
Zoom is not allowing me to share my screen. I don't know why. If you don't mind, can you please share the presentation? I can talk on that one.
Okay. I will share your presentation, share. Please wait a minute.
I'm using MacBook. With some security reason, it's not allowing me to share my screen. Okay, thank you so much for sharing the screen. Okay, so today's topic is like from zero to millions, how applications scale effortlessly on cloud. So we use cloud mostly for the scalability, you know. Let's go to the next slide. We'll start talking on these parts. Thank you. So whenever we are using some application from our phone or computer, MacBook or tablet, we like to have a really good experience, not like no lagging, without lagging and slingshot performance, flawless performance. We like to have those features. And whereas the same application can be handled by numbers of users globally. So globally, millions numbers of users will be using the application. The server has to reply back to the users where they are the application getting operated from, either from more mobile, from your tablet, from the computer, and so on. And growth has to be exponential growth. We look for exponential growth. Like, so suppose the sometimes during a day, the morning 9 o'clock or 10 o'clock, lots of users try to access the application. The application should work flawlessly without any performance hiccup. And that's there. In that place, the cloud starts playing up the role. Can you please go to the next slide for me, please? Okay. So current challenges of the scaling in cloud application. The traffic spikes is one challenge, the cost optimization, latency, and infrastructure limits. So what is traffic spike? Traffic spike, I just told you that whenever like sudden load can crash unprepared systems. That means what? Like if your server is prepared to handle 100 user concurrently. If suddenly like 1000 users are coming and trying to access the application, your application will crash. Your server will stop responding. CPU will go overshoot the limit, and at the same time, memory will go overshoot. That time, the application will be completely unresponsive. You will not get anything out of it. So that's how like the sudden traffic spikes can kill a application or make the application slow down. Cost optimization, like if you have a server, like a very big server, and sometimes your load is like 100 user and server is capable to handle like 10,000 users, and during a day or maybe out of like 1 month, like only 10 days you have like 5,000 to 7,000 number of concurrent users, but rest of the days you have like 100 to 200 concurrent users. That means you're over provisioning the system and wasting of money. Latency also, like because of the load, it can also increase the response time. That's the latency one. And infrastructure limits, there are like, if you think of like three-tier infrastructure of a particular application, so it could have the different, in the different layer it can be having different bottlenecks, like the application bottlenecks, the database bottlenecks. So we will discuss about these bottlenecks in the next slides. Can you please go to the next slide for me? Yeah, this is a typical three-tier web architecture where you can see the application layer, presentation layer, and data layer. So you can see that we are using some AWS services. The Amazon Cognito is a authentication tool where where user can get authenticated themselves. And Amazon CloudFront, S3 bucket, and website assets can be a presentation layer, and where user can use their mobile phone, or user can use their tablet or computer to come into this layer, and then be, using the API call, using the AWS API, Amazon API gateway, or the session call using the load balancer, or the AWS load balancer using the Lambda can be a backend, or EC2 instance, or different compute service can be a backend. And the data layer would be like it could be Amazon DynamoDB or any kind of database. That's a typical three-tier web architecture. So it has bottom the scalability can have, we have to do the scalability, we have to maintain the scalability and each and every layer, like presentation layer, application layer, and data layer. We will talk about that, how we will create how we will maintain the scalability each and every layer in an industry-based application. Can you please go to the next slide for me? Okay. So same thing I just discussed about how you're using your presentation layer, using the mobile desktop clients. The presentation layer can be supported, built using the JavaScript, React, Angular, and Python, and many more. And communication typically happens over the REST APIs, or the different kind of like session calls and all. And we are using we use different kind of AWS services in presentation layer to increase the scalability of the application. We will discuss in later slides. Can you go to the next slide for me? Yeah, the application layer, where we have mentioned in this slide like EKS, Lambda, and ECS. And the application layer can also consist of EC2 or simple compute AWS compute services. And application layer mainly consists of backend code. It could be the Java, Node.js, Python, or different kind of like application code, what you prefer to use in your application development. Can you please go to the next slide? And the data layer actually we use the data layer to fetch or retrieve or write the data, like especially for the card operation, create, update, delete, those kind of operation we use the databases. So user comes through the application layer to the presentation layer, um, presentation layer to the application layer, and application layer talks to the database and get the data out of it and reply back to the user. We can use different database services provided by Amazon or non-Amazon, even the GCP or any kind of traditional database. Uh, we can use like AWS RDS or normal SQL Server, PostgreSQL, Oracle, and so on. And DynamoDB, AWS RDS and DynamoDB are provided by Amazon. We will discuss about the scaling, how we will be scaling the databases in coming slides. Can you please go to the next slide? Okay. So coming to the slides, like whenever we talk about the scaling of an application, like the scaling means it will handle the million number of users or 10,000, 20,000 number of users at the same time with the same performance. So we talk about there are two types of scalings are available. Two types of scaling technologies. So one is the horizontal scaling and the vertical scaling. One is scale out, one is scale up. So what is the difference between two types of scaling, and why we will be needing one scaling on another? So what is our goal? Like goal is to reduce the latency, increase the performance, and applies in a different layer, like we talked about, application presentation and the data layer. So we will discuss in a few slides how we will be achieving the same. Can you please go to the next slide for me? Yeah. So the horizontal scaling. Horizontal scaling means what? Suppose you have an application or online banking application or online e-commerce application where you have a compute service called one server. Don't think of EC2 instance. EC2 instance is the compute service provided by Amazon. You have like one server is capable handling like 100 concurrent user. Okay. So adding one more server can handle 200 concurrent user. Adding one more server that can handle 300 concurrent user. That means if you are keep on adding like 10 similar size of server one by one, those server will be able to handle 1000 concurrent user. Whenever it is needed, I will add the server. Whenever it is not needed, when my traffic spikes is low, like we need only like 50 user, 50 concurrent user, 100 concurrent user, or 200 concurrent user instead of 1000 concurrent user, we will delete those servers. We don't need those servers because our goal is to increase the performance, but at the same time, we want to be frugal. Like we don't want to pay like lot of money for the server. This is where the horizontal scaling comes up. Like you can keep on adding the server, same size of server. If we need to add, like if we see the traffic spikes are more, or your application is like your application processing is taking more resources, then we will add. And if it is not, we will remove. In that case, horizontal scaling come up. Like that means we are actually like increasing the server and decreasing the server. Here in this example, you can see that from 2 instances, we can go up to 10 instances, and it can go in infinite number of instances based on the requirement. Can you please go to the next slide? Okay, and what is vertical scaling? Vertical scaling means we will continuously increasing the server size. Instead of increasing the number of the server, we will increase the server size. That means what? Like to first we had suppose if you think of like we have a 4 core and 32 gigabyte of memory one server, and it is capable to handle 100 concurrent user, and you need 200 concurrent user. So you just scrap the server and create a server, or you are buying a server of 8 core and 64 gigabyte of memory. Okay. Now your business needs like 1,000 concurrent user, and you do the calculation and you come up with like, okay, I need like 16 core or like 24 core and like 256 GB of memory. Okay. So that means you are purchasing the number of like the higher instances or higher like server, the heavy server each and every time you are actually, when you actually need more concurrent user, or your application needs more resources. That means you're increasing the size of the server instead of the number of the server. This works great. And previously in our, like, before cloud came into the picture, and in your legacy or traditional one, this used to work great, but it has a serious limitation. That limitation we will talk in next slides. But why we came out from this kind of scaling, and we are using the horizontal scaling, I will discuss that one. And which cases we have to use, and we don't have any choice using the horizontal scaling, we will be using, and we are continuously using the vertical scaling. I will discuss in next slide. Can you please go to the next slide for me? Okay, this is a simple comparison between the horizontal scaling and vertical scaling. I already discussed over the, like, I'm going to discuss it in detail. I already discussed some of the points. Like flexibility, horizontal scaling is high and vertical scaling is limited. That means what? You can keep on adding the number of servers one by one whenever it is needed, and it can grow exponentially. It can grow unlimited. Like, you don't have to worry about, okay, today I have like 1000 number of servers, tomorrow I can have 2000 number of servers, day after tomorrow it can be 3000 or like 300,000. Doesn't matter. Like, if you have money, if you have a requirement, you can increase the number of the servers as you like. But the vertical scaling, where the server size has to be increased, like 16 core, 30, like 256 to 6 memory and all, like, it has a limitation. Like, you cannot go beyond some higher number of your CPU memory, your IOPS, disk IOPS and all. Like, it has a limitation. So the vertical scaling has a limitation. Now you talk about the downtime. Downtime, like in industry, everybody like worries about the downtime. Like, if your application is down, suppose you are using a banking application, or you're using some kind of, like, your e-commerce application or some kind of your university application, and you need some information, and you suppose if you see your application is down, it's not working, it is giving you 500 error, and you will not like it, and you will get frustrated. And user, definitely everybody gets frustrated with the, like, if you see your application is down. So what, like, in that case, like, if you are keep on adding the server while your previous servers are still in business, and you can add new servers to bring them live, and and it can actually start serving the user needs. But for vertical scaling, we have a downtime. Like, every time you change the server size, you have to power down the server and power back on the new server. That means you are just removing one server and adding new server. So it has a downtime. Every time it has a downtime. Cost efficiency is a pay as you go. Like, our cloud is always pay as you go. It's a cloud service. Is You can think it as a renting service. You are you're renting electricity, or you're renting some car, or you're renting something. Like, you're using it, you're paying it. If you're not using it, you just stop paying it. You don't have to worry about paying anything. And for vertical scaling, since you are buying the higher number of server, like the big size of server, so you have to pay hefty cost. And also procurement, like, if it is an industry has to go for the particular procurement of a particular infrastructure product. Like, it takes days to procure a particular inventory. And complexity, like, it has a complexity. The horizontal scaling comes with the complexity. We need some of the different services to support this horizontal scaling, like load balancing, and different kind of stateless is required, and different kind of load balancings will be required, or different categories of load balancing will be required to support the vertical scaling, in order to send the traffic data from the user to the particular server. And for vertical scaling, it's just a one mapping, like one-to-one mapping. You don't no need to use any load balancer. So limits, I already talked about the limits. It can scale independently, but it has a like vertical scaling has a hardware limit. You cannot procure more than the maximum you can procure. I don't know. I don't know the particular number, but you have a hardware limit that which you can procure, which is available in market. Can you please go to the next slide for me? Yeah. So where we the scaling will play in role, like so data, like if you talk about the web layer, we have the horizontal scaling. We application layer, we have the horizontal scaling. For the data layer, like data layer, we are still using the vertical scaling. I'll tell you why we are still using the vertical scaling. And we have like horizontal scaling supportable databases. We will also discuss that one. So can you please go to the next slide? Okay. Here we are talking about the scaling different layers. So with the architecture diagram, we already talked about it, but let me tell you once these things in once again. So if you have an application like your app.com, using Amazon Route 53 is like DNS services provided by Amazon. Your request comes and directly hit the load balancer. So load balancer actually what it does, the load balancer. Load balancer actually balance the load between you or the user and the servers. Suppose you have like two servers are supporting your application and 100 user is trying to access the application at the same time. So load balancer will see that okay, I have 100 concurrent user, I have two server. Load balancer know how many server it has. I have two server, so I'll be pushing 50 user in one server and 50 user in another server. That's how the load will be balanced. At the same time, the two of the server will be equally occupied, and the CPU and the memory will be optimizedly used. Okay, so that's what the load balancer does. Like in case of two, if we have like 20 web server, and it load balancer also does the periodically check with the server whether the server is still online or the servers are still capable to serve the traffic. So that's how the load balancer do. And whenever it gets the request, it sends the load to the different server based on the routing policy, or based on if it is like no routing policy, it sends the loads one by one. Okay. Now you come to the application layer. So this is where the load balancer and also the application layer, it does sends the request based on that, based on the load balancer decision. And it could application layer and can contain a different data source. It could be a cache data source, Redis cache, or different kind of cache source, or it could be a RDS, or it could be RDS, Amazon RDS, or any kind of database is supporting the data layer. So, and you can please go to the next slide for me. Yeah, so let's talk about the web layer first. So we use there, you can see in the diagram that there is like two availability zone in the region one, and the region two, another two availability zone, and there are multiple servers are there in the availability zone. So if you know about the availability zone is the inside every region. Like AWS has like like lots of regions, and inside the region, to make sure the application are highly available, we have like different data center inside the. You can think of it as a different data center inside a AWS region that we call it as the availability zone. It can go availability zone 1, 2, and 3 like that. So every availability zone has like multiple servers. And you can see the load balancer is sending the traffic based on the request to the different availability zones. Suppose your availability zone 1 goes down, load balancer will only send the traffic to availability zone 2, or else vice versa. Okay. What auto-scaling group does? Auto-scaling group is a group we define inside the availability zone, where we define like suppose, and I can set a rule. Like rule is like if my application like web server CPU goes more than 75% for 5 minutes. My website, suppose my web server CPU is high or above 75% in use for more than 5 minutes, I will deploy another server on the fly to support the load. That means what? Like whenever the load auto scaling says, okay, my I have like 300 concurrent user. My application server CPU is high, like 75%. I have to deploy another instance. So that's how it will keep on deploying the different instances in a different availability zone intelligently by its own. And that's how we actually takes care of the scaling into the web layer. Uh, and there could be a different kind of load balancer. Here we are talking about the elastic load balancer, where elastic load balancer distribute traffic evenly across the instances, supports the health check and fault tolerance. I just talked about it. Like it will check the each and every web server like critically whether the server is capable to serve the traffic or not, and like work best with stateless web servers. So can you please go to the next slide? Okay, in the application like or the business logic layer, like we have like different AWS services which does provide this particular category. Like it could be ECS, EKS, AWS Lambda can provide as your backend where you can deploy the code. ECS, EKS, especially the containerized technology, and Lambda is a serverless technology. So it has its own scaling capabilities. ECS ECS, the containers can scale based on the given requirement, like your application concurrency, your different kind of scaling matrices, and also like if you're using the for AWS Fargate, you don't have to think of underlying infrastructure like any instances or compute infrastructure. It can scale independently. And for AWS Lambda, it is also same. If you actually increase the number of concurrency, it can handle like millions numbers of requests at the same time. Can you please go to the next slide? Okay. Now you talk about the scaling bottleneck. Now we talk about the RDS. Why we need still we need the vertical scaling for the RDS. RDS is a technology like where we cannot go for the horizontal scaling. Okay, normal databases, not no, no, go to yeah, normal databases we cannot go for the horizontal scaling. We have to go for the vertical scaling. That means what? Suppose you have like T3 instances, like T3 is the minimal instances, and it is supporting like 200 number of users. You have to like if you need like more number of users or content users to support your application, you have to double the or increase the size of the database. Okay, because of the database also depends on the database engine and different kind of mechanism. So we cannot actually go for like keep on adding the different database to in order to support. And there is a concept of cluster database that is out of the scope of today's discussion, but to support the higher number of workloads, we need to have to increase the size of the databases. And if you talk about that is the normal database. If you talk about the DynamoDB and Amazon Aurora, DynamoDB they can scale indefinitely. You don't have to worry about the scaling. You don't have to worry about the maintaining the underlying hardware. But because of it maintains by Amazon, it's like you like it actually can scale indefinitely. So can you please go to the next slide? Okay. So we already talked about the load balancing part, how it works. Uh, so how it actually improves the availability, fault tolerance, scalability. While load balancer works with the auto scaling group and the auto scaling group along with the servers in order to scale up your applications. Okay. Can you please go to the next slide? Okay. So there are like different type of load balancer we can use in AWS: application load balancer, network load balancer, and gateway load balancer. And it uses like um, various kind of traffic like global traffic or TCP UDP traffic, HTTP HTTPS traffic. So let me tell you one good example of network load balancer. Suppose if you're using any IoT based product like your Alexa or Google, like in the background it uses a network load balancer because it uses like TCP UDP traffic. Suppose and you're if you're using a web application or website, I typically use the application load balancer. Or if you're using some website like internationally accessible websites, sometimes it uses like or the company has a policy to deploy their website in a different region. Or for the data study for you can use the gateway load balancer. Okay, yeah, I can just go to the next slide. Yep. So handling like million requests per second, like we discussed about that one, how the scale, auto scale works and how the load balancer works. And this load balancer actually suppose the SSL termination. SSL termination is like you see that how you get the HTTPS or your secure network connection. So the secure network connection terminate SSL can be terminated in either in the server level or either in the load balancer level. Our load balancer does support the SSL termination. And WebSocket is like a TCP based communication protocol where user and between the user and the server there will be a handshaking mechanism. User sends a request, there will be a handshake, then server sends the request back and the HTTP request. Okay. And the CloudWatch, actually, CloudWatch, how you will know, how the system will know that your system, like your servers are going like more than 75%, or CPU is going more than 75%, or network bandwidth is choking up. So that's where the CloudWatch actually comes playing the critical role. CloudWatch actually monitor the servers, monitors each and every parameters, and based on the parameters it keeps on reporting, and based on the reporting the auto scaling groups actually picks up and start spinning the new servers and adding the new servers to handle the million numbers of equal requests every second. Yeah, can you please go to the next slide? Okay, so database, I talked about the database, like scaling database is hard, but it is crucial. That means what? Like I know that there is a like horizontal scaling is difficult with the traditional databases or most of the databases we use till now in the market. But there are few databases supports the Amazon Aurora or the DynamoDB can support the vertical scaling, not the horizontal one. Uh, and why the scaling database is crucial because it has to like application will grow. Not only the application, if we are scaling the presentation layer or the application layer, not scaling the database, your application will eventually fail. You need the proper database response in order to keep the application running or get the response back to the user. So here we use the different mechanism to handle these kind of problems. Uh, can you please go to the next slide? Okay. 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 We can skip this slide. Can you please go to the next slide? Okay. So how we'll be handling the databases? Like database is like either in AWS we have like a technology or we have a way to use the read replicas. Read replicas means what? Like you have a database, it's a heavyweight database where you are using like you can say of like uh, eight core or 16 core or like 256 GBs of memory, but the database is heavily occupied. Heavily occupied means what? Like hundreds of people are hundreds or thousands of uh, processes are reading, writing the data at the same time. So how you can offload or how you can make the database little bit happy with the lesser number of process to be worked on. So in that case, you can create a read replica. Read replica means what? It's a asynchronous based writing mechanism to another database instance where the primary database will still support the writing mechanism, and the secondary database within milliseconds, those like new logs or new data will be written to the second level like replica database, and the replica database will be processing the read request. That means we are able to divide the database's work based on the read and write to make sure that our database works less and the application performance increase. That's where the read replica comes into the picture. So in AWS, because we know that with our scaling, like we cannot keep on adding the database instances, but we can smartly move that one, like the reading part in a different segment, different machine itself or different instance itself, and keep the writing the data into the main database. That's how we can make the database happy and we can scale the application at the same time. Go to the next slide for me, please. Yeah, Aurora serverless and future of database scaling. We discussed about it that AWS Aurora and DynamoDB has a scaling mechanism. It can scale hundreds of like Aurora serverless can handle like thousands of concurrent connections. Scales in milliseconds, not in minutes. Amazon Aurora does have that capability, and even the DynamoDB does have the capability too. And it automatically goes or like it goes the storage, it automatically goes the compute of like DynamoDB and Aurora based on the request, based on the load on the database. So we don't have to worry about like read replica or like scaling like the database over here. But for the all the other traditional databases, like if you talk about the AWS RDS like PostgreSQL or the or the SQL database or Oracle, we have to increase the database size and use the read replicas to support this database scaling. Can you go to the next slide for me? So this is a typical example of like Amazon Prime Day, like the how the system actually scales up like million number to support like 100 million number of users, because Amazon like that particular website is like it's like globally. Although you see your like country specific details over there, but the actual main website is deployed globally, and we have like customized for each and every country based Amazon services. But during the Prime Day, we see like there are massive spikes of user requests. Like they keep on looking for best deal, keep on looking for different kind of products at the same time purchasing the products, and but you always get a seamless approach and seamless experience while using the Amazon. How? Because of this, all the scaling technologies, what we discussed so far, we are using here with Amazon.com. So that's how we are able to serve million number of users at any time. Yeah, so the overall architecture requires extremely scalability, reliability, and fault tolerance. Can you please go to the next slide? Yeah, so we are at the end of the end of the end of the presentation. So scaling, the best practices of scaling, like how we can scale based on the different matrices or requirements based on your application. Some application may needs IOPS, some application may needs a CPU, some application may needs memory, latency, or some kind of anomaly detection, or some kind of error code. Like it depends actually based on like what is your application is actually doing and what is your requirement. But generally, if you talk about the general application and which is being used worldwide, most of the times we look for the CPU, memory, and latency. So if you we can create a target-based scaling policy, like where the CPU is more than 70%, we can add more servers. Where we can see that for 5 minutes continuously, CPU goes less than 70%, we can delete the server. And the auto scaling group will do the same. Like it's not only add the new servers, whenever it sees there is no load or the load got gradually reduced and it is more than 5 minutes or 10 minutes down the line, it will start terminating the servers. By that, you don't have to pay like if you're auto scaling in deploying like 10 servers during the day. You don't have to pay the 10 servers for a whole day or maybe like next month. You just have to pay for the number of hours you use those servers. That means at the day beginning of the day, if you have one server and you're paying for one server continuously, and during the traffic spikes, is add another two server. And once the traffic spikes goes down within an hour or so, you just paid for for an hour for the new two servers. You don't have to pay like total three server for overall whole day. So the scaling actually it can you can think of elastic. It can expand, it can shrink. Both of the two way it can work. So it always based on the monitoring and scaling policies. Cost optimization, like cost optimization is very much needed because if you think of like organization wise cost model, like organization the single organization may use like hundreds of servers and which cost like hundreds of thousands of dollars every month to maintain those servers and work with those servers. So that's how the cost optimization is much required when your application doesn't need that many servers or the resources. You can release those resources. When your application needs resources, you can bring them online on in live. And by that, your customer is happy, your management is happy, and your application is works good, your database is happy, your overall everything is happy. And design fault tolerance and elasticity, like you can distribute your servers between the various availability zone. I told you like inside the region, suppose you have a region A. Inside the region there could be multiple data centers. So if your one data center goes down over like say power cut or anything happens, your another data center will keep on operating. So if you are losing, like if you are deployed like 336 number of servers, where your three servers are completely gone, but your application will keep on serving the traffic because you already have the another three servers ready. But if you are using only one availability zone, your three servers are gone, you don't have anything left, or like whole availability zone is down, that means your application is down. So designing of the application plays a critical role over here. And the load balancer auto healing. Auto healing means what? Like your load balancer sees out of six servers, two servers are got corrupted or two servers are not responding at all. It could be like a complete crash. The server is in deadlock status. So that means it has to like it will auto scaling group will automatically terminate those servers and bring the new servers in live in order to support your application. Okay, so build stateless services though can so that they can scan horizontally and store session data in the external stores like Redis or DynamoDB. Like you're storing the session data in a Redis or DynamoDB, or you can also write in a different cache or different layer of like EFS as well. Uh, so yeah, that's how we can use and we can architect a system to support the scalability in different layer and make it fault tolerant, highly available, and at the same time your application is completely cost optimized. Can you please go to the next slide? Yeah. So I just want to finish with that. Cloud scaling is not just about the growing fast; it's about doing it intelligently and monitor everything, optimize code aggressively, and design for resilience from the day one. So if we are thinking of using your application in cloud, either you can go in a different direction at any time. You can end up spending a lot than what the application is actually needed, but you can also move in a different in a smart. You can also have a smart move. Okay, I will use these resources whenever it is required. I will not use anything whenever it is not required. So I'm not going to pay Amazon extra dollar in order to not doing anything, but I will definitely serve my customer with a highly efficiently flawless application experience. And monitoring comes in a key role, plays a key role over here. If you don't monitor the CloudWatch, if you don't monitor your application, how it behaving, you don't monitor your servers, how it is behaving, like your servers, how the servers are going, like it's going crazy, like it is going like your um, application is more than like 60%, 70%, your CPU is hitting a 70%, 80%, 90%, you're actually hurting the performance. So that time you have to add more resources to it. And yeah, design for resilience, like from the day one, because once you build the application and design is completely flawless, your application will be resilient enough in order to support one user, even million number of users at the same time. Yeah, that's all from my end. Thank you so much. I'm ready to take some any question.
Thank you, Mr. Siladitya, for a wonderful presentation.
Mhm.
Now, Mr. Siladitya will take any question for our audience. You could put your question in chat or you raise hand to ask directly to Mr. Siladitya, to our speaker, anything about Mr. Siladitya presentation today. Silakan rekan-rekan apabila ada yang ingin didiskusikan atau ingin ditanyakan, boleh di kolom chat langsung atau raise hand untuk bertanya. Ah, there's the first question from Muhammad Fatullah. Thank you very much,
Mhm.
Mr. Siladitya, for your session. I'd like to ask in general, how can we manage load and apply pre-service scaling and optimization in a cloud environment, regardless of the provider, to maintain performance while minimizing costs?
Okay, let me read the question once again. How can we manage load and apply per service scaling and optimizing in cloud environment regardless of provider to maintain performance? Yeah, so if you are talking about the stateless application and your application can, if you're thinking of like using the ECS or different container or the Lambda, you can actually scale that particular Lambda or like where the your particular piece of code is deployed instead of scaling the overall whole architecture. So by that you can minimize the cost and you are also scaling your particular piece of code or particular piece of functionality instead of going for overall holistically scaling approach.
Okay, thank you for your answer, sir. Uh, there is a next question. Okay, maybe the next one is from me, sir. Which one is always more cost effective between the horizontal scaling and vertical scaling? Is there any base from our requirement or horizontal scaling always be more cost effective, sir?
It depends actually. It depends on the requirement, you know. Like it is completely based on the your application needs. Suppose if you're like if you think of like okay, your application needs like just the like 200 number of users. Just your current system is supporting 100, and your application needs the 200, and you don't see any growth further. Okay, and at the same time you don't want to go for cloud, and you know that 200 will be a constant number. So that time it is better to go for okay, let's make the size of the instance of the size of the double it, because you're not going into the cloud. You are using you are maintaining your own data center, and you are just double the size, you're doubling the size of the server, which is much convenient because you don't have to think of the complexity over here, like adding the load balancer, adding the auto scaling features. Your technology is limited, you don't have to worry about all these different layers of abstractions and all. But if you're thinking like, okay, I have like 200 number of users. At the same time, someday I can have only one number of users or 10 number of users, but someday I can expect like 1,000 number of users. So my application has to be flawless and it has to work seamlessly. So that time it's better to go with the vertical scale, horizontal scaling instead of a vertical one.
Okay, thank you very much. Yeah. Ah, there is a next question. Thank you very much, Mr. Siladitya, for the successful presentation. I'm curious, if a web or application still store file directly on the server, could ELB cause problem when traffic switch from instance A to instance B and the uploaded file isn't there yet?
Yeah, that's a really good question. It sometimes yes, but you there in the ELB there is a option called sticky session. Suppose if your application needs to have like the sticky session based mechanism, that time like your application will keep on redirecting the traffic to the particular instance whenever it is required. Suppose it is possible that when your file is getting written, your instance dies or your web
Mm,
server dies, then it will start directing the traffic to the next instance. And definitely, if you are thinking of like, okay, I have a server, I have a EVS volume attached. Suppose if you as an architect you are designing such an application where the application has to write some data in the server level, so you will not be writing into that server level disk, you will be writing somewhere where it is like shared based storage like your EFS or NFS or different kind of S3 bucket and so on. So if your server dies but your new server comes or ELB started shifting the traffic to the new server, but you still have the file stored into S3 bucket or some EFS where it can be accessible.
oh. Thank you very much for your answer, sir. Is there any more question from the audience? Ah, there is another question, sir. Hello, Mr. Sarma. Thank you for the explanation. If
Mhm.
it is related to digital business, how to use the cloud to increase flexibility in application development? Maybe it's more the general question, sir.
Yeah, cloud will increase the application development, right? This is not today's topic, to be honest. And like, if you're I would like to give you some general overview. Like, based on the requirement, it's always like any application, anything, how you're developing the application, what are the application is actually going to do your application, and how you can make it as a stateless application, or else how you can break the application, break the different functionality apart and keep the functionality to be moving independently. Based on that, you will be choosing the different cloud services. Okay, and that's how you can come up with a different way of development of the application.
Okay,
So if
thank you
you,
very much for your answer.
I will keep similar to that topic in our next discussion or next to next discussion, where we will be talking about the application development using the cloud and using the various AWS services, where that this particular question will be more relevant, and we will discuss in detail about that one. So you will have a clear idea that how we will be actually using the different AWS services for your different needs.
Okay, thank you very much. We're really looking forward to our next session, sir.
Mm.
Maybe the closing statement from you, sir, about our today international guest lecture. Is there anything you would like to say to our audience, sir?
No, no, no. It's a really quiet audience. I don't have like I never had this much quiet audience so far. But yeah, it's good to connect with you all virtually. Yeah, looking forward to talk more about the different AWS services and different cloud services to teach you like how you will be using the cloud services and how do we use cloud services for our day-to-day activities in our industry with the like Fortune 500 clients. Like I work with like hundreds of Fortune 500 clients, the top companies. Even I work with the Facebook client, Facebook as a client as well. So I know how they're using cloud, and we will discuss about more about all this. Just feel free to write or shoot me some kind of topics you want to hear from me. I'll be definitely will be able to coordinate and discuss on those topics effectively.
Of course, of course. Thank you very much for your today lecture, sir. We're really looking forward to our next one.
Mhm.
Untuk para audiens, tadi juga Mr. Siladitya menyampaikan apabila ada topik-topik yang ingin dibahas, ditanyakan, tentunya kaitannya tentang cloud computing, beliau sangat berharap sekali. Silahkan boleh menghubungi saya atau menghubungi Departemen Prodinya nanti. If there's any related topic would you like to discuss about cloud computing, about AWS, uh, Mr. Siladia would like to bring the next lecture depending on your interest. Yeah, for the audience, please tell our department, tell me personally what would you like to discuss in our next session. We will held our next session regarding to that topic. Okay, thank you very much, Mr. Siliditya, for today's presentation.
Mhm.
Before we end it, maybe we would like to documentize it,
Mhm.
uh, to take screenshot to our meeting. Ibu Nelly, bisa dibantu untuk foto bersamanya. Rekan-rekan semua boleh on cam untuk diabadikan terlebih dahulu kegiatan hari ini. Aba-aba dari saya atau dari Ibu Nelly? Dari Ibu Nelly silahkan.
Kamera belakang. Boleh dibantu, Pak?
Oke, silahkan on cam dulu semuanya. Kita ada 3 halaman, 4 halaman yang bisa kita abadikan. Untuk halaman pertama, senyum terbaiknya akan teteh semua. Kita abadikan bersama. 1, 2, 3. Oke. Untuk halaman kedua, ditahan senyumnya. 1, 2, 3. Di halaman ketiga kita abadikan. 1, 2, 3. Oke, terima kasih Akang Teteh semua. Thank you very much, Mr. Ziladitya Sharma, for today presentation. We're really looking forward to our next session. And maybe we would like to thank you also to our student and our lecturer that also join us today. We'll see you soon. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Terima
Thank
kasih
you.
semuanya. Thank you very much, Mr. Siladitya.
Okay. Bye. Take care.
Terima kasih semuanya. Pamit.